There's one thing that even the best YouTube videos about the twin paradox keep getting wrong, and that is when they try to explain what makes it that one twin ages more and one twin ages less, given that they are both in equally valid reference frames. And the two most common explanations you'll hear is either it's due to acceleration, in which case it's actually really a problem for general relativity and not special relativity. And the other one is that it's because one twin switches reference frames. Therefore, he's in two reference frames versus the other one who's in one reference frame. And somehow that is at fault. Now, these are both wrong. And to show why the acceleration is wrong, I'm going to share a variation of the twin paradox that you can find on YouTube. And I'm going to use my old graph from my last video. And the variation is, instead of twins traveling back and forth and having to accelerate and decelerate, you have clocks that are following inertial reference frames, straight lines. They're traveling at a constant speed. So one clock whizzes by Earth at time zero at 60% of the speed of light. And then another clock is whizzing along here, and they just happen to cross each other at this location out in space, 3 light years away from Earth. They get synchronized, so this clock copies the value that this clock is reading as they pass, and then he keeps on traveling and ticking along, and then he passes by Earth, and then the difference is measured between what was read on this clock at this moment in time here on Earth as it was flying by, and this clock here. And in this case, there was no acceleration, and you'll come up with exactly the same results. So you can stay in strictly special relativity, no accelerations needed. With the twins, of course, you're simplifying, you're neglecting the effects of acceleration, which would also have some time dilation component. You're just neglecting that so that you can stick to the strictly special relativity kinetic time dilation components. So back to the other explanation. The other explanation was that, well, because this one changes his frame of reference, that's why he ages less. Now, I guess you could interpret it in different ways, but if you interpret it to mean that the more frames of reference, the less you'll age, that's wrong. And it's very simple to show that. It's not hard to find a case where you can have one twin, let's call this the first twin. He flies off, and let's say relative to Earth, just to make it easier to talk about relative speeds. So he flies off at a greater speed relative to Earth in one direction, whereas the other twin flies off with a lesser speed relative to Earth in the other direction. This twin turns around, so here he's traveling 25% the speed of light relative to Earth. Here he's traveling back to Earth at 50% the speed of light relative to Earth, which would be a little bit more relative to what he was doing before. He doesn't stop at Earth, he whizzes by, and then he changes once more. And here he's flying back towards Earth at 25% the speed of light. This is where they'll have their reunion, the two twins. This twin comes back. So here he's flying off at a little bit more than 80% the speed of light. And here he flies back relative to Earth again with 80% the speed of light. Now, and I'll turn on the hyperbola points because this makes it easier to see how much time passes at this point and at this point. So you can see the intersection of these green and red lines on the vertical axis. That tells you how much time has passed. So to fly out here, it took him 3.3 years, and it'll take him 3.3 years to fly back. That gives him 6.64 years for his whole journey. This one, it takes him 3.87 years to fly here, 3.47 additional years to fly over here. So flying back towards Earth, passing Earth, out to another point in space, 1 light year away from Earth, and then another 3.8 years. This is the same speed and the same distance as this one here at the same time. So in total, if I got my my arithmetic right here, it's 11.2 years for the twin who had 3 inertial frames of reference on his world line, and this one had only 6. And basically what it comes down to is how long are these lines, right? Like if you just look at the length of this line, purely XY length, no Lorentz transformations, nothing. Or actually you can do the Lorentz transformations, you can shift this and it'll always be, this one will always have a larger length than this one, because this one is staying closer to the straight line from, in this case it's E to F. So this one stays closer to E to F, so his line is going to be shorter. This one flies further away from the EF line. His line's going to be longer. It's the one with a longer line who ages less. And that line will stay longer no matter how you transform this into different frames of reference.